Today I'm alone here. I'm Alvise, product designer of Scotail. And the first thing I want you to ask is just to confirm if the audio is working well. Arthur is saying yes, it works. So perfect. Let's start. So I'll go straight to the topic of this week's webinar. As you might be in a webinar each Tuesday. This is sixth session, changing topic each time, talking about different problems with printable files and how to fix this problem, how to design for printing. And today we are introducing a new topic, and that we have interlocked website, because I want to first say a couple of words about what interlock part means. So an interlock part is an object. It's compound of several parts, and these parts are assembled and moving each other. And this kind of configuration, it's possible only through 3D printing technology, since this is an already assembled configuration that can't be manufactured in any other way except for through additive manufacturing, layer by layer, and no need to extract any part from the mold. So this kind of complexity, it's possible. As you can see here, so I access the material page and I click on one of the materials available, and I found the design guideline page. And scrolling down, you can find this section where I just stopped, and it's that it deals with this enclosed and interlocking volumes. So there are, of course, some constraints and signs to keep in mind when designing objects with this kind of features. I want to show you a couple of examples of printed objects with interlock parts. So first of all, a keychain. It's a small keychain with a figurine attached. It's actually my body. It's kind of my body. As you can see, there are 4 rings that have been printed together and cannot be separated except if you want to accept breaking. And I have a caliper as well that is made of 3 components that are printed together and moving, and it's functional object. It can be used to measure things, and it's quite amazing. This is one of the features that I love most manufacturing, mainly for the fact that this is not possible in any other available technology at the moment. So I was talking to you about design guidelines for interlock parts. Of course, a lot of design freedom is allowed by this characteristic, but we have to keep in mind, I would say, 2 main things, and this is the topic of the webinar. Actually, one, the most important, is called clearance. Clearance is the space that 2 interlock parts need to keep. In this example, I'm in the design guide for selective laser sintering, and the minimum clearance it's set to 0.5 millimeters. This means that these 2 parts needs to distance at least to not be fused together during the printed process and make all the object stuck. not moving as we wish. Second main guidelines is to provide a clear path for the powder that is stuck between these two parts, between interlock parts, especially when the clearance that we are designing, it's very small. When, for example, we want to create parts that have a quite tight size movement, like the caliper here, we are using as few clearance as possible. We need to provide what I call a straight escape path. So an easy way to extract the unsintered powder between the parts, and since this will be extracted manually by our technicians after the printing, yeah, we don't want it to get stuck in there, so that the part will not move. I will show you two examples to describe these two problems and show you how to solve them quite easily. So let's go to the first one. So let's start talking about clearance. I have this example. It's a strap watch, and it's made of, I think, are 11 components in a row, and it's been given to us by one of our users, saying that it's right in our resin material with as a rigid object. It was not able to move this part and use it as a real uh, strap. So let's take a look why this happened, and let's try to find it out. I'm using a cutaway view, finding the good axis. Here it is. To watch inside and see how these parts fit. So we can clearly see that the two parts are separated. I mean, all of the parts, 11 parts, are separated each other. These red lines are as the separation line, and there is some space, at least in a part here, that it corresponds to 0.1 millimeters, and almost no space in this other side. So this is clearly not the right configuration we want to create a interlocked part. That's the reason why this object is being printed and fused in a single part. So what I'm gonna do now is to solve this problem. So modifying this geometry, and to do so, I'm gonna use 3ds Max this time, because I think it's the right tool in this case. MTL, no colors are present in the object. Here is the part. So I need to modify the geometry in those parts that are touching each other. So let's check again, which are they? So I will say this face, I want to move it more inside, and so 0.4 further, since that's the minimum clearance for the resin material. And then I want this cylinder is containing this snap. to be bigger, precisely 0.4 in each size bigger, so 0.8 diameter bigger than what is now, so that my part will be able to move. I will make this modification only on one piece, one of these 11, 12, 12 pieces, and then just duplicate it so that it will be faster for me. So first I will select all the parts that I don't need with the element selection and clicking on attach, separate them in a different object. I don't want to link them for the moment to keep track of it. I'm just gonna select them and hide selection. And now I have just one object. Since the object is perfectly symmetric, I also don't want to work on its entirety and repeat all the modification I'm going to do. So I'm deleting half of it and work on the half and then apply symmetry modifier at the end. My viewport now to make it fit the dimension I'm working on. It's a very nice tool where you feel that the viewport movement panning with your mouse is not respecting the dimension of the object you are working. Okay, now I feel comfortable with this. All right. So first, as I said, move all this face further, 0.4 millimeters further. Check if the dimension of the parts are correct. Yes, if you 4 millimeters in the Z, yeah. You can find all the dimension about the parts in the utilities tab, this hammer symbol on the right top of the screen. So let's go back to the modify tab and use the polygon selection to select all the part that I want to move away from the rest of the body. I'm now just select polygon, so I want to select all this planar face together. So I'm using this option or ignore vertical edges, and then I want to play with the threshold. So this is too high. I will bring it down at around 10 and okay. I select everything I want. So all I have to do now is select and move to move the space, and to move it precisely the dimension we want. I right click it and this window is opening when I can set precise dimension. The X one is the to move is the X axis, and now is set to minus 4.1. So just make a test calculation. I want to move it 0.4 further. So this number has to come down 3 point and press enter, and the face moves. So this part is done. I think I want to do is make the inner cylinder bigger, 0.8 in diameter, to include the snap. You can see this other side of the part, and so again, selection, polygon selection, and keeping the same threshold it worked before, and select part to scale just this part to a precise dimension. I need to detach it first from the rest. So in creating a second object, select it, and now I have a separate object with its own pivot. so that I can scale it, keeping it in its center. Um, First, I have to bring the pivot center. As you can see, the pivot with its gizmo now it's further, it's far from the object. So hierarchy tab and affect pivot only in the adjust pivot. So then alignment and center of the object. It moved in the middle, my new object exactly. So I'm now able to scale it correctly. Again, to scale precise dimension, axis, uh, and as you can see, the dimension is the same in these two axes, since it's a perfect cylinder. So 1.958, and I want to add to this diameter 0.8, since it's to reach the clearance I want. So I'm at 0.8 to this number, and this is the diameter 1958, and I obtain this number, and I want to bring this to a percentage that I can use into this max to scale the object properly. So I will multiply this number 100, it's moving, and this is what I obtained. So 140.8% bigger than before. I copy this number and I paste it in the Y and Z dimensions. As you can see, I press enter and then the part updates. So this is the right dimension to make the part fit with the proper clips. I now have to refuse this new scale part with the rest of the body. As you see, there is some geometry here that I want. To do this, I will first close this part and make the better section. So I will compare it to medieval poly because I want to close this hole here, and do so I need to select the border of the hole. This is done only if the part is first converted to an editable poly and not an editable mesh like it was before. So editable poly, border select this part closed. I also want to select this face and select and move to bring it a bit further and create a better intersection. I unhide again the object Now they intersect properly. I am able to boolean them. So select the main body. I'm going to create tab, open this window here, select compound objects, and choose pro boolean operation. The kind of boolean operation I want to use in this case, it's the intersection, because I want to this part of the main body, and I also want to keep the inner part of the cylinder that it's intersecting here. So the right tool is intersection in this case. And I'll start picking to run, and immediately it updates, and I have now just one object on the left stack. Okay, so now I modify this half part properly, move the face and make the cylinder bigger so that the clearance is reached. I last couple things to do is mirror it with the symmetry modifier. Slice along the mirror, select it. Well, Max is not answering. It crashed. Okay, never mind. It was finished, by the way. So we have seen how to fix the clearance problem, and last couple of things to do before the crash. It would have been just to apply the symmetry modifier to body I was modifying, then copy 12 times to reproduce the old strap I was trying to fix. So we can, I think we don't need to go back to reopen Max and conclude these couple of options. They're very simple. And yeah, we covered, I think, the example, the dealing about clearance guidelines for interlock part. So we can proceed and go to the second topic, the second main design guidelines. And as I introduced before, the second concept to keep in mind is about how to create a proper path for a sinter polygon. To do so, I'm using a second model, 3D model that I made myself some months ago. I've been asked to create a compass to be printed in just one part, so that its movable parts are interlocked each other. And that's the model that I've been working on. I've been creating Inventor now with a CAD model and not anymore with meshes. Because we're printing the configuration that you're seeing now on the screen, and we result uh, uh, was a was a component that was not moving. All the parts were stuck together, even if the right clearance is kept between these three parts. So as you can see here on the left, on the stack solid bodies group, if we select them, there are three parts. There are moving in a relationship with each other through this gears in the middle, and then this middle part is together. And just visibility of this part, so you can see the gears. So there is space between these parts, and there is space between these parts and the third body. This is a proper infuse, and the not sorry the powder between these parts couldn't be removed by our technicians. So I want to show you how we afterward we modified this file with just a couple of adjustments. We obtained a proper interlocked object with movable parts and printed it correctly. So let's check with the cutaway views. And first, I'm in the old compass now. I'm taking the inspect tool and section. Show you first the horizontal section here. So from this section, you can see that what I define as straight escape path for powder is not present here in the middle between this powder that is center and is very likely to get stuck in this part, as the escaping path is quite complicated and difficult for it. And of course, I'm using the minimum clearance as possible to make these parts, all the object more precise, so that it can be used as a proper design tool. Here I have a straight escape path, so no problem here, just here. We'll do that. Let's check the second section in the other axis, apply it here. Also in this second axis, I see I have no escape path for all the powder will get stuck in here. So paths that are straight here and here, but even with the pressure hair or sandblasting machines that our technicians are using, this powder will just get stuck in this area and make everything not so straight escape path. This is the result. So for the problem of the powder between the two gears in the middle, we solve it, creating these couple of holes. Powder can come out straight from here, and changing my tile to shaded with edges. And as the second problem between the gears, applying again the section view, we provided a different architecture, so that in this way we have straight escaping path for powder. As you can see here, now the powder is out from top, the sides of these moving parts. There's no more any where the powder can get stuck in a corner, the blind corner as before. So we printed this correctly in a polyamide through slightly larger string, and yeah, found out we learned something from this. If you're interested, you want to get to know more about Inventor, I'm showing you now quickly how I got from the first model to the second one. I just made a couple of modifications that I can quickly show you now here. So first of all, I have three parts. Two of them are the two arms that are exactly the same component, just mirrored and moved the work on at the same time, and no, I I will have no to make this modification twice. So combine tool and select first as base and second as tool body and click apply. And now I have just one object for the arms. So what I want to do first is project on a sketch on the top of the middle component the diameter of the circle that is now in the gears. I want to the middle object. Projected these two diameters. Sketch the later, and so visibility for that component that we're going to modify later because we still need it in the configuration it is now. Next step, I want to close these holes in the arms. So delete faces tool and selecting the inner faces of the cylinders and the heel option checked so that the holes will be closed and I still have a solid. Then I will create um, a plane that is the mid plane with two planes are top and the bottom of the gears. So now I have a plane exactly in the middle of them. I want to create a sketch on this new plane to extrude the kind of sticks to make this part move. The geometry, the base sketch for this new stick I want to create will be found in the middle component. I will again project its diameter that I haven't canceled on purpose on this new sketch. It's done. Alright, I finished the sketch as well. Hide the middle part. So I want to keep this middle part. I need it. What I'm doing now is extruding this new sketch I've just done. Since I need it on both sides, I need the extend between option and select the two faces that are defining the top and the bottom of the centerpiece. Click OK. My extrusion is done. We can check it and check the visible. All right, that's what I wanted. I can hide the arms.